Hi, my name is Mark Schvetz, and I'm a developer at Chariot Solutions. Yesterday, I moderated a really great talk by Jessica Kerr, and at one point, she and Avdi were discussing their woes with AWS SAM. It took a lot for me not to jump on the mic and not yell, "You guys should check out Architect!" And we're so happy to have one of my favorite Canadian speakers, Brian LeRoux, talk to us about that. Brian.
Hey, hi. Thanks, Mark. And thanks for having me at Chariot. I'm stoked to be here, and I'm going to share my screen. Whee! There we go. For all of y'all following at home, I just updated these slides online. You can find them at slides.begin.com whenever you want. This is a hastily thrown together modification on an older talk I've done about CloudFormation. But this talk is a little more specifically geared towards people that are interested in and want to deliver serverless applications using CloudFormation with OpenJS Architect, which is an open source framework for building web apps that I'm the maintainer on. So I'm also the CTO of begin.com. I've been a web developer for a hot minute, and I'm a sort of open sourcey guy. I'm a member of both Apache and the OpenJS Foundation. If you want to find me, you can generally find me in the bottom. We've got a link here to my Twitters, which I tend to hang out on too much, and to the projects themselves. So there's a few things I'm hoping that you can take away from this talk. The number one kind of main, big, important thing, I'm hoping that people come to the same conclusion that I've had, and that infrastructure as code is a crucial best practice. In my view, and I feel like by the end of this talk, you may agree, infrastructure as code is just as important as testing or even revision control. That seems like a really dramatic statement, but there was a time, believe it or not, when people felt that testing might be a step too far, too much work, you aren't going to need it. And I even remember really early in my programming career when the idea of revision control was still a little bit racy. People would literally copy and paste files around. And so nowadays we take testing and revision control for granted. And I really do believe that in the future, it'll be the same for infrastructure as code. If we get past that first key, that infrastructure as code is a crucial best practice, we're probably going to come to the conclusion that CloudFormation is important to that story. CloudFormation is the de facto standard for doing infrastructure as code on AWS, which is the leading cloud provider. And CloudFormation is not that great to work directly with. There's a lot of tools out there to work with it. We'll look at a few different ones, but OpenJS Architect is one of them, and I'll argue it's the fastest one. And this is important because it makes you faster. This is important to you because this means you get more iterations, and more iterations is a good thing. This isn't an opinion that I hold. This is actually science-backed, and you can verify this science for yourself. The DORA report is a pretty famous DevOps report out of Google, out of this link that you can go check out. But it's consistently shown that speed and stability are outcomes that enable each other. And these are properties we want in every software project. We want our software to be both fast and we want it to be stable. So if we know that speed and stability are outcomes that enable each other, and this is backed by science, and this is probably something that we want to strive to achieve with our code. There's two major points to consider when it comes to speed and stability in the DORA report and how they analyze that work, and that's deployment frequency and lead time to production. So how often we're getting our code from our machines onto that production web server or cloud function, and how long it takes to do that. If you are deploying multiple times a day, you have great iteration speed, you probably have a good lead time to production. That means that you're going to be faster. And a major key to being fast is determinism. So one thing that's not controversial is to say that we want to keep our versions in version control. This actually includes infrastructure, and that's kind of the key idea to infrastructure as code. We check and manifest file in with our code that represents the resources that our cloud function, or that our cloud is going to need, that our code depends on. One way I like to describe this to newer developers is infrastructure as code is like a lock file for your cloud resources. So it's very common for us to have lock files for Node.js or different tools that are out there, like Cargo for Rust or whatever. And this is code dependencies. And so your code has these dependencies. So we put this lock file in and we can make sure that we get the same deterministic build every time. Infrastructure as code is the same thing. We have a lock file, but it's describing what resources our code's going to run on. So faster lead time to production through determinism is good because that means more iterations. And more iterations means more chances for you to get it right. This is really important if you're a startup because this means you get more chances to find your product market fit. Time is money. We probably didn't get that code right the first time. We're going to need an iteration to make changes to whatever we discover. And the faster we can get those iterations out, the faster we're going to find product market fit. This isn't just crucial for startups, but this is crucial for big companies to remain competitive. Google didn't fire all the software developers after it shipped search and hire sales guys to sell ads. They had to keep iterating. And it's the same for any software. Once that software is out there, it's going to need to be maintained. It's going to need to be updated. And in order to do that, we need to have good iteration speed. We want to have better lead time to production and better determinism so that we can get the outcomes that we're looking for. So all of this leads back to infrastructure as code. And there are a whole bunch of these practices that we've been sort of building up over the last 20 years to get to this point. And as we're sort of reviewing each of those practices and looking at how we got to this point to better understand where we're probably going to go with it. So we know software development's hard, and we know software delivery itself is really hard. There's a lot of things that we're doing today that make it easier and make it more deterministic and more predictable and faster. Stage delivery is the first kind of key thing. We always have stage delivery. There's no project that doesn't. You're always going to have it working on this local machine. And then you're probably going to be deploying that thing to production. So you always have two stages to start with. At some point, you're going to have a bug, and that bug's going to bring down production. It's going to be bad. And at that point, you'll probably implement some form of staging environment. And often with time, you'll have more than one staging environment. And it's very common to see things like a QA environment and a dev environment, a test environment, and then finally there's a production environment. So no matter how you look at that, though, there's always these three stages. There's always some local machine, there's always some stage environment, or more than one stage environment, and there's always production. So that's worth noticing because this is really important when it comes to infrastructure as code, because we need to have these environments be identical. If you have a bug in production that you can't reproduce in your local environment or staging, then you're not going to be able to fix that. You'll have to fix it in production, which is maybe not a desirable state to be in. Static analysis is another tool that we often employ for creating stable, high-quality software delivery. This includes types, linting, scanning tools that look for dependency problems. So it's a really useful step that we pretty much across the board now apply to every software project. There's all kinds of testing tools. You can do whole talks on this. There's manual testing, unit testing, integration testing. How you go about this is probably varied and probably changes with time and depends on the project, but nobody's denying that you have to have some form of tests with your applications these days. Continuous integration is an idea that's getting a little older now, but still pretty new to some groups. The idea is that we're writing code against our master trunk and merging back in as often as possible to stay as close as possible to whatever's being delivered to the customer. Continuous delivery is kind of similar to this. So integrating back to the trunk isn't the same as actually delivering the software to production. There's slightly different steps. And it's kind of like dovetails with the idea of GitOps and DevOps. So all these practices together are pretty common now. We do this stuff all the time. We didn't always used to do all this stuff though. When we were sort of in the early days of Ruby on Rails, there was a fresh amount of people moving into Linux deployments, and we were discovering that it was really hard to scale these stateful monolithic apps. They needed to be spread out across a whole bunch of stateless instances where we'd remove file system access and we'd separate the database, and it became an orchestration problem. It became difficult to deal with all this stuff. And so there was a whole suite of configuration management tools that came out of the challenges of that. Capistrano, Salt, Ansible, Chef and Puppet, SaltStack, etc. And these tools were sort of like infrastructure as code 1.0. This was the first sort of stab at the idea, like, can we create an artifact that gives us a reproducible build every time? Rails also sort of popularized the idea of convention over configuration because we just started having so much configuration, and that configuration drift became its own problem. Really like this boils down to effectively how we name stuff and where we put it. Totally normal to have a Rails developer be able to hop into any other Rails project and find where all the assets are because they have a common folder structure. This is not necessarily the case all the time, but it's something that the better frameworks take care of for you. At that time, there was also the 12-factor app. You've probably heard of this if you're doing any kind of back-end dev. This is a link. This is a strong recommended reading for anyone that's interested in high-quality software delivery. And it's getting a bit long in the tooth. This was actually ideas proposed by Heroku quite a long time ago. And there are principles for how to build applications robustly. And I strongly urge everyone, if you haven't checked this out, to check it out. They're foundational ideas. They're very important to how things have evolved. Could argue that today a lot of that has actually been just subsumed by the cloud, and the 12-factor app is just how stuff works kind of now. But it used to be steps that we would discreetly take and ideas that were somewhat controversial when they first came out. So that kind of leads us to where we are today, which is infrastructure as code. This is where we treat our cloud resources as dependencies. They're stored alongside our source code, and they're thusly versioned. So if you have a version of the code, you'll have a version of your resources that they expect. You'll get a deterministic build. There's no running CLIs or checklists or hoping that the server patch that you just ran didn't bring everything down with some new behavior. Everything should be deterministic, and Demdepend always works the way that you think it does. And not to belabor it, but we want this because it makes us faster. We want to go home at 5. We want to have more at-bats. We want to take that swing that gets a home run. And for our list of required practices, I will argue that infrastructure as code, if you're delivering software to the cloud, is one of those practices today that you can add with stage delivery, static analysis testing, and CI/CD. So with all that said, we can now hop into the world of how to get into IAC. This talk and Architect are focused on AWS. This isn't to say this stuff isn't portable to the other clouds that are out there. Architect is not currently portable to any of the other clouds. We're still waiting for Azure to catch up on a few of its serverless primitives, but we're definitely very bullish on its future and where it's going. So if you're not doing stuff on AWS, that's okay. The other clouds should catch up eventually, and you can do some of this on those other clouds with different providers. Not all of it though. So Architect has its own file format, .arc files, and it generates SAM. But SAM is serverless application model, and that's Amazon's cloud native format that's based on CloudFormation. I'm sorry if this is a little nebulous, but basically SAM is CloudFormation. Architect creates SAM. So these are not mutually exclusive. They're all totally dependent on each other, and they all work together. Serverless framework is another alternative that's out there that's absolutely worth your time checking out. It's kind of the granddaddy. It's been around forever. It does a lot of stuff. They've recently moved to a components model. If you check out serverless components, they support many clouds, and they're very serverless focused, as you can imagine. Terraform's the other big player in this one. From HashiCorp, they're a little more traditional server kind of thinking, not really serverless out of the box, not really thinking about building serverless web apps out of the box, more just a generic cross-cloud solution, but really great solution. It's got a lot of users. I want to also give a special shout out to Stackery, which I've linked up here. They do CloudFormation generation from a visual GUI, which is pretty cool and a different way of looking at it. So each of these formats, at the end of the day, talks to a cloud, and they do it in different ways. So most people evaluate software based on how many GitHub stars it has, And I want to invite you to consider adding some rigor to your selection criteria, which could include the license, the governance, and how it works under the hood. So Architect is just a fancy way to generate CloudFormation from a high-level manifest file. SAM is basically writing straight up CloudFormation, which has drawbacks, but is a way to do it. Serverless and Terraform are both using SDK calls. Serverless Framework does use CloudFormation in its 1.0 product, but its components product, its new, I guess Serverless 2, I don't know, version is SDK based. And Terraform is also SDK based, and that's got some problems. So it's worth noting that that's where those ones are. I've got a link here about the governance side. I'm an open sourcey person, and I believe that open governance is important. I'm not trying to say that there's one way is better than the other, but I do feel that it's worth looking at for your selection criteria. So again, the .arch file is OpenJS Architect's manifest file. And when we deploy, we actually just turn that into a SAM document. And then the deployment is all done with the AWS SDK, which ultimately turns SAM into CloudFormation. So that's how it works under the hood. But it's worth noting that we didn't start off this way. And I feel this is really important for people to start grokking now while they're on their cloud journeys, because things are changing fast out there. SDK deployment was the initial way that we did things because it had a lot of advantages. First of all, CloudFormation was not supported across the board for the services that we wanted to use. So we needed to use the SDK. We didn't really have a choice in that matter if we wanted to use those services. And it's pretty great because it's very fast. And it's also great because you're completely in control of the entire life cycle. And another reason I liked it a lot was that there were no config files. So you wrote your code and it deployed that code. And you're probably asking yourself right now, well, what's the downside of an SDK then? Well, that sounds like all upside to me. And the downside of the SDK is the TooMany RequestsException. So if you have more than one person calling the AWS control plane through the SDK, one of them is going to get throttled. And so using SDK deployments is really only tenable if you're using some kind of a queue in front of it, or you only have one developer doing it at a time. This might be okay. This is something you can absolutely do. But if there is a throttle in that deployment process, you may end up with a non-deterministic outcome. You might end up with infrastructure you didn't expect. And that's not a desirable state to be in. So the SDKs might be fast, but it's also brittle. And in my view, brittle is basically the same thing as broken and slow. If you don't have determinism, then you're going to be second guessing your deployment process every turn of the way. And that's not a desirable state to be in. And the reason for this, again, is because you have to own the entire life cycle of the SDK. And so owning the SDK lifecycle means that you have to implement backoff, retry, and failure, and you have to queue that stuff. And then you have to do this for every service that you use. And then you have to multiply that by every Amazon account that you have. And this takes a lot of code. This takes a substantial amount of code. So I'm not saying that you can't do this. So what I'm not saying is that you can't do a better job than Amazon. I absolutely believe that that's possible. What I am saying is it's probably not a very good use of your time to be doing that. And this was us to us. I'm not admonishing someone's use of tools out here. I'm talking about us right now. So we realized that this was just becoming an untenable situation last year. Amazon had updated all of their serverless services to have full first-class support for CloudFormation, or at least the services that I cared about for serverless. And we embarked on the inadvisable trip of doing a big rewrite. We rewrote Architect from version 5 to version 6 into CloudFormation, and we ended up deleting almost 20K lines of code. And in that process, we added functionality. So if you tune out now, or if you're tired of listening to me talk, or if you don't take anything else away from this talk, take away this. By moving to CloudFormation, we were able to substantially delete a large amount of code while gaining features, performance, and determinism. And so if today you've put together your own deploy process that involves the SDK, I strongly urge you to reconsider. that path and take a look at what CloudFormation can do for you. I also want to say the AWS SDK is still okay to use. This is not a binary situation where they're mutually exclusive to each other. In fact, you're probably going to have to use both. There are times when, believe it or not, Amazon has bugs. And when they have those bugs, sometimes you need to patch them because you can't wait for them to do that. And if that's the case, the SDK is going to be your friend. And we've had to do this a fair bit. There's a second use case, and I love demoing this, so I'm going to do it at some point in this talk when we get into the demo side of things. But sometimes you want to use the SDK to just deploy something really quickly. And you can combine these techniques. You can find the resources inside of your application, and you can run SDK calls to deploy directly into your infrastructure, and it will be very fast. And we'll take a look at some of that. So CloudFormation is growing in popularity. It's been around a really long time, but people are starting to come around to the idea that infrastructure as code is important as a first sort of like epiphany. And once you reach that epiphany, you have to ask yourself, are you going to go and use a third-party solution, or are you going to go straight to the metal and use, the de facto cloud solution for that? And I think a lot of people are arriving at, well, this is how Amazon's doing it, and we're running on Amazon. This is where we're going to go with it. I've heard people raise the specter of lock-in, and I want to address that specifically. There's a few notes on lock-in. So one aspect of lock-in is that you're afraid that Amazon's going to raise prices. In the 10 years I've been an Amazon customer, they have never raised prices, and they have really strong competition from Azure and others. And I just am not confident that there's going to be a moment when Jeff Bezos twirls his evil mustache and decides to raise the prices on AWS. That's not their business model. Jeff Bezos is very famous for saying, your margin is my opportunity. So this stuff is approaching zero. It's not going to get more expensive. The other exception I hear about lock-in is, well, what if they break me? And if you've done any work with the AWS SDK, you'll know that they don't break APIs. They don't change APIs ever. If you look at S3 in particular, there's a whole bunch of APIs that are suffixed with V2 because they didn't remove the V1 stuff. They actually literally hard-coded V2 into their API calls. So I don't think you have to worry about AWS breaking you. I don't think you have to worry about AWS raising prices. So the last sort of objection that you would have would be portability. And I would like to invite the user to ask themselves, portable where? You don't get the same capabilities and features and services on any of the other clouds unless you abstract them completely away, defeating the purpose of using a cloud in the first place. So I don't really buy the lock-in myth. I feel that CloudFormation is a completely acceptable thing to choose to use. There are downsides to it. It's not perfect, but it's the best that we've got at the moment from the market pioneer and leader. There's some other notes here about what to look at. So the service coverage isn't always what you want. Sometimes there are services that come out for CloudFormation or come out for AWS that don't have day one CloudFormation support. They're working on fixing this. This isn't always the case. They have a standard packaging format. It's called the Serverless Application Repository, or SAR, which I'm quite excited about because this is going to allow you to package up portions of your application and reuse them as components. And yeah, so this isn't to say CloudFormation is perfect. I have a slide here about some of my issues with it. If you've ever worked directly with CloudFormation, you probably have some issues with it. First of all, the performance isn't always great. It's gotten a lot better in the last year. It used to take multiple minutes to get something up. Now it takes maybe a minute and sometimes less, which is wonderful. There are SDK calls that you have to make, package and deploy, or sorry, CLI calls in order to use CloudFormation directly. These should be SDK calls, not CLI scripts, but I hope that they will eventually address that. There's currently a kind of gross implementation detail. You have to have a bucket, a region where you're deploying. That's where your assets will end up when they're being staged for deployment. And it's just a weird leaky thing that I hope they get rid of. Another thing to watch out for with CloudFormation is that you can automate disaster just as easily as you can automate your success. And in particular, I'm talking about retention policies. They're a little bit nebulous. And so if you make a change to something that maybe accidentally drops a database table, that could be bad. So it's something you have to watch out for with your stateful resources. And this is something worth noticing. There's actually a few different kinds of resource, but roughly you can group your resources by lifecycle, things that are stateful, like database tables and S3 buckets, and things that aren't, like API gateways or SNS topics. The other sort of big issue with CloudFormation is that it's got really bad error messages. So sometimes debugging can be not super fun. And a lot of people end up just using a third-party tool like Architect to get around that. There are other issues with CloudFormation that Amazon can't solve for us. So AWS is not going to get smaller. They're not going to have less features next year. They're not going to announce that they're getting slower and that they're going to be harder to use than ever before either. But they're not growing simpler and they're not growing less complex. And CloudFormation in particular is very verbose, which is a lot of stuff to do a very simple thing. And it's getting too complex. They're not ever going to have any less capabilities. So the way we deal with this is by putting an abstraction on top of it. And this is where the other infrastructure code tools have come into play. Architect is an abstraction on top of CloudFormation. And it's an infrastructure as code manifest format that generates CloudFormation. And when we got into this, we were looking at the various formats and we had problems with them. We didn't like XML for the reasons no one likes XML. We don't like JSON because it's not really that human readable and it's got the same problems as XML. We checked out TOML, which is really syntax heavy and has the same downsides as YAML. And YAML is just super problematic in lots of ways. This is a link right here. Interop is a fiction, which I invite you to check out because it takes all the YAML parsers and breaks down how they don't interoperate with each other, how you'll get different results. And so, you know, it's just when I say that YAML sucks, it's not an opinion, it's actually a fact. So you can verify that for yourself. Terraform agreed with us because they created their own format. And so whatever, we created a format. People get upset about this idea, but I'm gonna dig into it more and I'm gonna explain how the format works and why we have a new format. So first of all, what was the essential complexity that we needed for that format? We wanted a config format that we could read as well as write. The sort of joke about CloudFormation is that it's a write-only format. You can't look at a CloudFormation document and have any idea what that application's about to do. And we wanted to get around that. We wanted this artifact to be useful for the consumer as well as for the computer. So we needed to support comments, which opts us right out of using JSON. We wanted it to support scalar types, so basic types, string, number, and Boolean. We needed complex types, like array and map. And then we wanted it to discourage nesting, and we wanted it to discourage syntax. And so it's our belief that constraints are good and that you can create a very rich experience without those not so nice characteristics. So this is the ARC format. It initially stood for Amazon run commands. We wanted to have a cool RC file like vimrc or bashrc. And we also wanted it to be hidden. We did not want to look at this file all day. The point of our app is our app. We wanted to focus on our code, not on somebody else's code or the framework code. So the .arc file is a hidden file, and it's a key value format. And so the first bit of syntax to note is the hash octothorpe, and that's comments. So this is a comment, and that gets stripped out. And then the keys, or pragmas, start with an @ symbol. And then each pragma, as you can see, supports the scalar types. So we've got a string, a number, and a Boolean, which turns into a string, a number, and Boolean. And then this other pragma, this other key, shows that we can support complex types like arrays and maps. This is the depth that you can nest it to. And the only syntax that we have really are the pound, the @ symbol, and white space. So now you know the format. And we're going to dig into building some stuff with this, but we're just going to talk about a few more concepts first. So a while ago, a really smart person said primitives over frameworks, or primitives, not frameworks. And it's really resonated with me. It connected with how I like to think about application architecture. I don't want to think about the framework or the vendor. I want to think about the component entities that make up my application and my end user experience. I want to focus on my core business value and the undifferentiated work. I don't want to focus on the stuff that everybody else is doing better than me. This person that said this was Werner Vogels, and the CTO of Amazon, also a renowned techno enthusiast. And I just loved the thinking of it, and it really, really resonated. And it kind of clicked. I was like, wait a second. All AWS services are a bunch of primitives, and I can compose those how I want. And this was a big epiphany because I was pretty intimidated by Amazon before that. You know, if you open up that console, it is a nebulous, scary experience. You don't know where to look. You have no idea where your app is in there. It's spread across a whole bunch of services. And those services are multiplying like rabbits. So we're just getting new ones every day, and who knows how they affect each other. You know, like do I modify something here? Does something happen over there? But what we realized was if you treat them like primitives and like a big box of Legos, it gets a lot more tenable to deal with. And even better, if I focus on my business problem, my differentiated value, I can look at which services I need and subset Amazon to the stuff that I want to use. So OpenJS Architect is just that. We have subsetted Amazon down to the primitives that you need for building a web application. We took 8 services and we just separated them out and said, okay, well, this is what it takes for us to build a web application, a stateful database-backed web application online. And we wanted those things to be generic. We don't want to talk about their service names, which are frankly quite often terrible or hard to Google, or both. We want to talk about our app. And I don't want to talk about I don't want to treat my app like a NASCAR, which is being stickered with all of Amazon's products. I want to talk about my HTTP layer. I want to talk about my eventing. I want to talk about, what the queue, the cron lambda, the scheduled tasks. I want to talk about a database table. I don't want to talk about Dynamo. I want to talk about the static assets. I don't want to talk about S3 and S3 buckets. So we genericized everything, and we built things in for just these services. And then we gave you an escape hatch called macros, which allow you to modify the generated CloudFormation on the way out before it gets deployed. So you can use all of Amazon. Everything in there is accessible to you through CloudFormation. But we make these things really easy. And we feel that these are the things that you need to build an application. You're going to need a CDN if you're building a web application. That's kind of a given today. You're probably going to have static assets. And by the way, you don't have to use all of these. You can opt into which ones you need. So if you're just building a static website, maybe you just need these 2 things. As soon as you want to get involved with using stateful trusted backend logic, you're going to want a Lambda function. That's where HTTP comes in handy, which gives you a direct hook into API gateway. If you want to do pub/sub patterns, fan out patterns, asynchronous message delivery patterns, SNS is the way to do that, and that's just events. Queues, so if you want to do ordered message delivery of some kind, first in, first out kind of thing. Queues and SQS is a really great product for that, one of the oldest Amazon products. If you want to schedule a Lambda function to run like a cron task, and this is kind of the gateway drug for a lot of enterprise serverless usage. People out there at a big code definitely have cron tasks running, doing all kinds of stuff. So this is a good one to get started with, but scheduled tasks is incredibly easy to get a Lambda up running. You're going to need some kind of state. DynamoDB is a wonderful database, and then finally, you might need something. You might need to draw outside the lines, and if you need to do that, then we offer macros for doing CloudFormation directly. Okay, so this is an architect application. This is the Hello World application, and this is the dangerous part. I'm going to start live coding. So I'm going to jump over to my desktop. I'm going to make a directory, and I'm going to call it today. And I'm going to touch an ARC file. ARC does support JSON, TOML, and YAML. And it also supports not using the hidden file. But we're going to do this sort of vanilla way. I'm going to modify that ARC file. So we're going to give it an app namespace. So this is just a namespace. And we're going to open up an API gateway, and we're going to hook up the get handler to the root. So my directory has nothing but an ARC file in it. I'm going to pop a terminal here, and I'm going to run arc init. And that's going to quickly generate some code for me. And so let's take a look at that code. If I hide my files, all I have here is source HTTP get index. And what's nice about this ARC file, get foo, get bar with a parameter baz, post foo bar, I don't know, you get the idea. Arc init, step back, great. So you'll notice here in the right where my file system has, we've got each one of these, and each one is an individual cloud function. And it kind of mirrors the ARC file, which is hidden. So we don't have to look at this all day. We can just hide that, walk away from it. And what's beautiful about this file structure mirroring this infrastructure manifest file is that we now know where everything is. There's no questions about where to find things. There's no grepping around. If there's a bug on getFoo, then you know which cloud function to look at. So let's run this. We're going to mount that on my local file system and kick a browser, and we can see the hello world. This is another aspect to Architect that kind of sets it apart from other solutions that are out there, and that we have a first-class local development experience, and that's really important to us. Sometimes people say this isn't possible. I don't know why they say that, because this is not actually that hard. Amazon doesn't change services all the time, so they're pretty easy to mock out, and there's plenty of ways to do that. And we do for all of our services that we support. So for those 8 services, you can use all that locally, and we've been doing it for years now, and it's fine. When we look at this function code, you'll see, oh, my terminal's all big right now, but you can make this a bit smaller. It's just a vanilla dependency-free function. Let's make some changes here so that this is a little easier to read. Hi there, Philly Online, and oops. Let's make this an H1. This is not the greatest HTML I've ever written, but there's no dependencies here. This is just, you know, no tricks up my sleeve, no extra runtime code. This is a pure vanilla Lambda function that's just running by itself. So nothing too spectacular here. We're just returning an HTML result. So let's deploy that. And this is going to take about a minute the first time, because we're going to go into CloudFormation, and we're actually going to generate a CloudFormation document locally. If I refresh, we'll see it right here. It generated sam.json. Let's blow this up a little bit. And it also generated sam.yaml. So the sam.json, the first pass at this was just the CloudFormation for serverless application model. And you know that because it's got this transform statement right here. I'd like to also point out, look at this. CloudFormation's been around since 2010. And AWS SAM has been around since 2016. Amazon's been doing this for years. They're way ahead. None of the other cloud providers have a native way to completely deploy a serverless application entirely through infrastructure as code without relying on third-party tools or SDKs currently. I'm watching Azure to fix that, but that's just where they're at today. So here's our app. It was just over a minute. Hi, Philly Online, not bad. 1 minute lead time to production. So let's, you know, first of all, let's check out this. Let's do a side-by-side. So this is, you know, a little more than hello world. This is 4 routes, but still quite small. 8 lines of code. The generated CloudFormation is 481 lines of code. Now, I'm not saying you couldn't write that. I'm just saying it's going to take you longer. And if you have a bug, which you will, good luck. you know, and there's nesting and weird rules and how do these things apply to each other. It's just a huge barrier to entry. And so you're going to want something that's a little higher level to work with and easier to work with. Okay, so we saw that get built, and that took it took 64 seconds, which is pretty quick. Subsequent deployments will be faster. So let's try that out. This will be faster. Arc deploy. It's going to generate a brand new CloudFormation document. It's going to upload that to S3 into a bucket that it created. It's going to take a look at all the stuff we created in CloudFormation and realize that all that changed was the function code. And CloudFormation is smart enough to do that. And it should just update that. And this should be a little bit faster than the last deploy. Wow, whoop, there you go. I was gonna hedge that for a minute. So about twice as fast, 30-second lead time to production, not bad. Let's take a look, see that it deployed. This will be faster, and it was, so that's good. That's what I wanted to see. But I mentioned this earlier, we can cheat too. We can do arc deploy dirty, and this will do an SDK deployment to the resources that are in control by CloudFormation. Now, this doesn't always work right away because it tries to do it as fast as possible, and if it gets throttled, it'll bail out. Which is funny, I must always get one throttle. But there you go. We just did another deployment. It was 2 seconds. Actually, we won't be able to see it, so let's, this is actually updated. Maybe less than 2 seconds. And just to make it even faster, I'm going to get rid of these other lambdas from my arc file. So it'll use the arc file to determine what to deploy. So we'll do another dirty deploy. And this is just parallel updating like the code directly. This isn't updating any of the infrastructure per se. Well, that was a little slower, weirdly, 4 seconds. But you know, 4-second lead time to production, hard to beat that. Now, I'm not saying that your lead time to production needs to be 4 seconds. You're going to have tests, you're going to have checks, you're going to have staging environments, you're going to have human coordination issues in between that. I'm saying the job of the framework and the platform is to be 0. We shouldn't be in your way getting your delivery to your customers. So that was the hello world. You know, that was just the basic stuff. How about a scheduled function? So you can see here that we've got a function. We declare the key scheduled. We're going to give that function a name daily mantra, and we're going to run it once a day. Let's just check this out. We'll just build a brand new app right now. Take a look at it. So I'm going to create a new tab, no tricks up my sleeve, jump over to my desktop. I'm going to make a directory, affiliate 2. We'll jump into affiliate 2. Oh, I copied that, so I'm going to PB paste to a .arc file. I'm going to arc init that, and we'll take a look at the code. So that generated the code. We've got a scheduled function called daily mantra, and you know, it's going to run once a day. That was it. That was the whole process to create a cron lambda, and I'm not actually going to deploy that. Maybe what I'll do though is I'll generate the CloudFormation, which we can do with a command called arc package, which will then tell you what to run on the command line if you don't want to use our tooling, because we really want you to be able to be portable in and out of CloudFormation directly. This isn't about us. This is about you getting your job done. So this is using EventBridge effectively. I think the old name was CloudWatch Events, but this is the code to create one scheduled function. That is, oops, 86 lines of code compared to 5. So better than a 10x improvement on what it takes to get that job done. This is a more involved application. As you can see here, we're doing a CRUD kind of REST thing here, using all the HTTP verbs available to us. This is, you know, an example, but it's a pretty good example. So if we'll just I'll modify this existing one, Philly 2. Oops. And so what do we have here? 1, 2, 3, 4, 5, 6 routes. Pretty unlikely to me that your production application only has one entity and 6 routes. You're gonna have an app bigger than that. And you're not gonna want to deal with the CloudFormation that takes to do. So this is 10 lines of code to 600, you know, and this is a lot of boilerplate. And if anything, you can use Architect as a tool to learn and understand how CloudFormation is authored and how it works, and possibly appreciate why you want to use a tool to generate it. So that's a REST app, but REST apps are kind of growing a little bit, you know, out of fashion at the moment. I think it's safe to say that GraphQL's, you know, feeling cooler. So this is an ARC file that describes a GraphQL endpoint, the API gateway, a static S3 bucket, behind it a CDN with a database table. So, you know, a full-fledged GraphQL app. And we have a little playground where you can check out the generated CloudFormation online. If you go to arc.code/playground, you can see the ARC file on the left and the generated CloudFormation for yourself on the right. But yeah, that's a big delta in your generated code liability surface. So this is just a big savings. You know, this is a reduction of configuration. It's less dependencies. It's just less overall risk and liability, and more speed, more iteration speed for you and your team. We, I think, have now gone through why I feel that infrastructure as code is a crucial best practice, just as important as testing and revision control. We had a pretty deep look into the CloudFormation argument. And then I hope a convincing little bit look at why OpenJS Architect could help make you faster for delivering that CloudFormation. I'd be remiss not to say that you should sign up for begin.com and check out how we do serverless CI/CD using Architect. And everything that we do is open source. It's a part of the OpenJS Foundation, which is the same foundation where Node lives. And you can find us on GitHub at github.com/architect/architect. And I think with that, I am cool to take any questions that you all might have.
All right, Brian, that was awesome. I think there's a lot of people with their mouths open, just looking at the screen. Like, I can't believe that just happened. So we have a bunch of questions. The first one is from Mark Mayer. It says, if I wanted to use TypeScript, do I just have it output to the locations the architect is expecting, or how does that work?
Yeah, we have some blog posts about this. There's a whole bunch of different ways. We actually use TypeScript ourselves a fair bit now, and I'm a big fan. We are transpiling straight into the directories. If you go to blog.begin.com, I think we've got content there about how we're pulling that off. Testing stuff. Oh, and we also support Deno, which, you know, if you're into TypeScript, Deno is super worth checking out. It's a little bit new, but here's blog.begin.com. You can see we've got some content on how to deal with TypeScript. You've sort of got two ways. You can either transpile your node, or you can use Deno, and both are pretty fun.
Cool. So a question from a Ken Rimple. Integrating security with Cognito. Is there an example out there?
I don't have an example, but I do have a website where we get into how to do OAuth without Cognito. So Cognito is a very powerful solution. It can be integrated using Arc macros. And if just for you, Ken, I will do an example app because I've had a few people ask me in the last few weeks, but I want to plug that we have a whole learning path that includes how to implement OAuth yourself. And you know, you can use Cognito, you can use a third-party solution. For begin.com, we implemented OAuth with GitHub. I think our total code for doing that was 30 lines of code, like no kidding, just really small amount of code. There's no way you can implement Cognito faster than that. And maybe for your use case, you could just implement OAuth instead of implementing an OAuth provider's solution hosting thing. Both are worth checking out. Yeah.
Eric Reese has a question. Supporting Swagger Open API for the endpoints would be really good. Is that something that's on the horizon?
Yeah, we do indirectly because API Gateway is what gets generated under the hood. Oh, let me see if I can get over to my console. Okay, so welcome to my console. Oh, I'm in the wrong region right now. Why am I in Ohio? So here's that app I just deployed. And we can look at it in CloudFormation and we can see, we've got some handy outputs here. We can see every resource that was generated. And one of those resources is a REST API for API Gateway. And if you wanted, I could help you script the thing to automate this. But if you're lazy like I am, you can just hop into the console and click on stages, staging. How do they do this again? Export. Open API 3, JSON, and there it is. So here's the API definitions for that API we just created. I can, if you ping me afterwards, I can help you write a thing so you don't have to do all this.
I like how it generates even more code. This is wonderful.
Yeah, yeah. So this is handy though because you can use these to bootstrap other APIs. And it is useful, and it's useful for docs and the other tooling that's out there.
All right, there's a question from a Keith Gregory. Question: how do you support HTTPS or custom domains, for that matter, a property on CDN?
Yes, there's a few ways because Amazon, but the way I recommend is to use CloudFront and ACM. It's a little bit of a manual setup currently because ACM is AWS Certificate Manager. It does cert issuance and renewal for you. You have to prove you are you to ACM to get a cert. But once you have a cert, it's really easy to set up CloudFront. And out of the box, it's also worth noting API Gateway is already HTTPS. So the only thing that isn't HTTPS in Amazon, bafflingly, is S3. I don't know why they did that, but they did, and it is. So if you are hosting assets in S3, they're going to be HTTP only until you put a CDN in front of them. If you're using API Gateway, you're already HTTPS by default.
Pretty cool. I think that is it for questions for now. Thank
Awesome.
you for stepping up last minute. That's a lot of time. So.
Yeah, no problem. Thanks for having me. I really appreciate it. And props to all of Chariot Solutions. I have to say I've been really impressed by an online conference that came together just so quickly. It's a rare thing and really speaks to how well that team is run, that you were able to get this together so quickly. So thanks for having me.
Thank you, and I hope you guys all check out Architect. Yeah, yesterday, like I said, I was thinking, this would have been great. Oh, this would have been great. No. So if you're doing serverless, you should totally check it out.